Here's a Feinwerkbau 127 tube, and I want to go through. This tube is really, really spectacular. If you notice, this gauge is graduated in 10,000, so just moving it around, you can see if I twist back and forth, I can make some, it moves back and forth. But at the zero, between the 0 and 1, that's 1/1000th, and it's 10 graduations between, so it's 10,000ths of an inch. If I keep it still and I move from the top of the compression zone here to the bottom of the compression stroke, I kind of dialed this zero into around a 0 right there. So you can see here from the top of the compression zone and trying to keep it still steady, not side to side, moving straight down, it's less than 5/10 of a thousandth. So again, if I even help myself hold it here, now I'm moving it from the top to the bottom. There it is. So zeroed at the bottom. So it's 10ths of a thou. I'm going around in a circle. And now coming back up. That's opening up a little bit. There's the top. Maybe 4/10 of a thou right there. 5 to 0. So half of a thousandth on an OEM tube, that's pretty good. This has not been honed on a Sun and Hone. The other things that I did to tune this up are, well, first of all, when you take these apart, always use gunsmith screwdrivers so that you don't bugger up the screw heads. A lot of these screws, like this trigger guard screw, very hard to find anymore. They don't make it. That's got a knurled underneath the bevel. It's just not, you can't find the screw, the OEM screws very easily. So using a gunsmith screwdriver, tightly fit, will not, the parallel faces, they won't ruin these screws. So the barrel pivot, which is in between the pivot bolt. The pivot bolts look like that. They have a set screw on one side and a bevel on the other side. The barrel pivot has been replaced from the original pieces that look like this. They're like a Bellevue washer, actually, or a Bellevue spring washer. They can compress and uncompress. I'm not really a fan of them because the barrel block is pivoting on that top of that conically shaped, oval shaped dish shaped washer. So they end up, it allows for the manufacturer that has a lot of variance in the build of this, because it can spring back and forth. It doesn't have to be so precise, so it has some give one way or the other. I prefer to self-fit a Delrin shim. I have a little jig that I can use, and I can actually sand them and adjust them by 1,000th or 1/2,000th I need them. I turned a bunch of them out of 1-inch Delrin rod on a lathe, doing a hole, making a hole about the same size as the original holes in the center, and then turning these Delrin little shims, turn a bunch of them, and I can work as I need to. Then I replace the steel one that's in the gun originally to one of these Delrin shims, and then I keep the flat steel washer on the other side. I have at times replaced them with Delrin as well if I wanted to center it or adjust the side to side where it sits. The other thing you can do if you have downward barrel angle, called barrel droop by people, if this is pointing down a whole lot, this one is pretty good. Sometimes you can see the margin along the edges of the steel here on the bottom or top. This OEM one doesn't really need any adjusting. It doesn't point down very much. If it does need to be adjusted, I usually use a file, and I file the underside of that, and you must hold it perfectly flat and in line. I use the saw, this is like an Oregon chain one from a chainsaw flat file, because it doesn't have any cut on the side. So it won't cut down here. It'll only cut forward on the top. 10 strokes will take 20 clicks on a scope up. If you don't want to overdo it, do a little bit at a time. You can take it off and then re-blue that plate. That flat area right there. Keep the angle perfectly flat. It's very soft steel, so it comes off very quickly. That is one thing that can be adjusted due to the barrel angle adjustment. I've done it a few times very, very successfully. Don't take off much. Take off only what you need, a little at a time. The other thing I like to do on the Feinwerkbaus is I take out the cocking arm pins, the original ones, on the deluxe models that have the strap, pivot, and pin. I don't really use a strap on these guns. They don't have a very strong ball detent in the first place. So if you have any pressure on the strap, you can lose accuracy and it can pop open. It's not the best design in the first place to have on Feinwerkbaus to have a strap on these anyway. Some people like them, but I've seen that there isn't a great amount of pressure on that ball detent. And if you ever rust anything while you're firing on that strap, you can actually cause the barrel to start to come open a little bit and have a lose accuracy on that shot, even if you're putting tension per se on it. The pins that are used inside here are very soft, and they're annealed, so when they press with a machine, they press and flare the ends out, and you can only drop oil in there. And I can run my fingernail across that pin, and you can feel the grooves that it creates. So I really like to be able to have a removable pen and be able to grease it with true grease like Veltar, Heavy Tar, and Molly, or something like that inside there. The other thing I do is with the punch set, I'll punch a 8.5 millimeter and a 5 millimeter small. With these punch sets, this is a metric punch set, you can punch shims out. And the shim, this one has a shim on both sides so that there's no wobble in the cocking arm, or not very little anyway. Now, side to side, so I shimmed each side with about a 4,500th piece of shim stock. And that's versus over doing buttoning or something like that. So it's perfectly centered, greased, and it has a removable cocking arm, a cocking pin. Here's a couple I can show you. I had them turned on a lathe. So there's a button on one side, or a top hat on one side, and then a groove for a E-ring on the other side. Then, like this, they get hardened. You have to raise it to 1600 degrees or more Fahrenheit with a torch, at least up to glowing red, cherry red. It loses its magnetic properties. So if you pull it to a magnet at that temperature, it won't attract to a magnet. That means you've got it to the right temperature. You have to hold it there for a little while and then quench it in like motor oil at 100 to 120 degrees, and moving it around so that it's the right, you cool it in oil. It will take on a color like that. Then we'll clean it off and put it in an oven at about 400 degrees for a couple hours to temper it so it's not brittle. That changes the steel so it's a hardened piece, because you need to buy it in like O2 steel to be able to turn it on a lathe and cut it. Once it's hardened, you wouldn't be able to cut it. So you get a steel that can be later post oil hardened. So the E-ring clips into one end and the other end, so you can see then I've got a shim on either side of that, and the pin is through the. I usually like to put the top hat or the top side on the Feinwerkbau where the logo is. It looks nicer that way, and then the E-ring on the back side. So that could be removed, and now you can lubricate that with grease. It doesn't rattle side to side. It's really nice and smooth. The next thing, I guess, we'll talk about the buttoning and the piston. Here's a piston. I put Delrin buttons in it. Usually on a Bridgeport mill, I would take a centering drill go maybe 55 thousandths. You go have about 110 thou on the tail thickness. You might take 12 to 15,000 turning it off of the edge, so you have more room so those buttons can stand proud. You usually have to grind that off. And uniformly spin it and remove a little bit of thickness on this back tail, so there's enough room to actually put buttons in and work on them. When you mill in buttons, I just do it the easy way. I just on a mill center drill, again 5 thousandths deeper than what you're going to do with the end mill. End mill you can't plunge without a centering tap because they're not center cutting, but this is a 1/4 inch end mill. I go about 50 thou deep. Then I use a 1/4 inch Delrin rod. I cut them off and have them cut them off flush, 90 degrees, and then I use Loctite 380 glue and glue them all in and let them cure for a couple of days. That's a little excess glue around the rods. You can see I just leave that. If you use acetone to clean off the surface of the steel in the glue, it really, really bonds that glue to the steel. It would have to be sanded off. It does not come off easily. So those are really glued in there well. So they're 50,000 deep and they're sitting proud 8 to 10 thousandths, about 6 to 8 thousandths each. You can barely feel it, but that's enough so that when the piston is in the gun, it's riding on the 3. So I always start with 1 at the top dead center of the latch. That'll be on when you're pushing and cocking the gun, it's going to ride on the top, and 120 degrees the bottom 2 on either side of the cocking slot. This particular, so that covers the piston. On the trigger group, there's a bunch of things with the trigger group. The trigger group, this one is already assembled and ready to go back in the gun. It's got a Jim Macari Air Rifle Headquarters aluminum trigger that I polished the bottom end up a little bit. Set the screw in where I want it. I got it all lubricated. I use Jim's Macari's clear tar, usually in the spring and the trigger in places, not much, but a little bit here and there on the springs and pivoting areas, pivot pins. The thing that this gun had was the threading of the trigger group was somewhat destroyed because someone who doesn't know what they're doing had this gun before me. And when they're putting the gun together, they start to tighten this down, they get it started, and they put a wrench on it and start pushing, getting this lug in. The metal that this is made out of is soft metal. It can be stripped out very easily. So what I had to do was machine with a 7/16 end mill after finding center on the Bridgeport, a pocket about 350 thou deep, and this was turned on a lathe and then post treated like those, hardened, a pressed fit, and then it already has the 8mm by 1.0 pitch threading in it. It was made on the lathe first, and then this pressed in, and then after it was heat treated, and then that basically repaired my threads and gave me hardened threads like the original piece. So again, if you are putting these guns together, the lug has to be put in by hand. Use a brass guide as you're pushing more or less pressure on the spring compressor to get this aligned, to get it lined up back and forth and forward and back so that this thing can be put in and fully seated by hand. It should go in perfectly by hand all the way in while it's in the gun under pressure with the spring. Not get it close and start cranking on it. You'll ruin the threads. And it's a major deal to repair that. As you can see, it took a lot of time and expense and parts to repair it to a like new or better condition. The other thing on these guns, try not to be ham-fisted when you cock them really, really hard. I had to change the one of the cocking sears because it's got a big dent there. That is from ramming. If everything isn't set, or someone's pulling the trigger or doing something goofy, this thing comes forward and can bang into this in a place it's not meant to be, or if they got gummed up or something. Cock these things deliberately and easily, not slam them forward, slam them to cock them and slam the barrel shut. That's the other thing that bugs me when people slam the barrel shut very, very hard. It can cause the barrel to bend upward over time. It hits it so hard and it stops instantaneously, and it can cause these guns are very sought after and nice guns. You don't want to ruin any parts on them because they're almost impossible to get. There's no spare parts available for the most part on most of the gun, except for springs and seals and things. That's the trigger group. The other thing about a trigger you might want to replace, they do have, you can get new springs that goes under the safety from Air Rifle Headquarters. And this is a Air Rifle Headquarters screw. It's stainless versus blued. And then this one has a blued one in it. Set that, there's the little E-clip allows a maximum travel up and down. So set it all the way up so that the top of the trigger screw is protruding to start with in the gun, and then slowly back it off to lighten the trigger pull. Once you lose the second stage, meaning it doesn't feel like it comes to a stop before firing, you've gone too far. There's no real way to it. There's not a lot of adjustment these things can have. You want a trigger that you can feel the second stage, where it goes forward, hits a bump, and then it fires. Taking that screw down too far, you lose the second stage and you don't know when it's really going to shoot. So that's one thing about adjusting the triggers. There isn't a whole lot of polishing. I don't even go into detail of touching up in the insides of the trigger because there isn't a whole lot most people can really do to improve the trigger pull. It's based on the spring tension and it's based on the set point of this. And there isn't a whole lot with the Feinwerkbau that you can do. It's a pretty good trigger if you know where to set that screw, not too light, and accept that it's not more of a match grade like Air Arms trigger or a record trigger. It just isn't, but it's very, very good if you know how to set this screw with the right place and live with that, feeling that second stage and its release. Finally, I want to mention a few things about the breech O-ring replacement and adjustment, as this can cause problems easily on this model due to design and varied tolerances. There is a small shelf under the O-ring that shelf has to contact fully to the top shelf of the detent lug on the receiver under the transfer port. There should be no gap between the surfaces caused by having too high an O-ring inside the barrel gland. This condition would make the barrel closing sit on the O-ring alone and leave a small gap in the metal shelves. It creates vertical and erratic groups while shooting. There is a very fine line where the O-ring is being squeezed, but not too much where the metal is not able to meet. While putting the O-ring in and out of the groove, I use 100% silicone shock oil used in RC car shock absorbers. It has a very high flash temperature and will not ignite when firing. Wipe off excess after putting it in. If the O-ring is too thick, then size it. Some FWBs need no sizing and some need a decent amount. The best way to do this is to size the OD outside diameter, not the surfaces mating to the bottom of the barrel block groove or the area seating against the receiver transfer port. An easy way to evenly do this is to put the O-ring over a small wood dowel rod, just big enough to slip over and have friction to keep it in place, not too large to overstretch the O-ring. Spin the drill and touch the outer diameter edge to sandpaper and it will take material off evenly. Cool the O-ring and dowel in the freezer if you like from time to time, as the harder material at a lower temperature will cut better on the sandpaper. While sanding, it will heat up and tend to melt versus cut. Do a little at a time and recheck fit and barrel closing often. Leaving slightly too tall is okay and best. At times, as time alone will push some excess out the bottom gap. You can see in the picture earlier. Doing this on the OD makes the O-ring able to compress and expand in the groove, thereby less thick without damaging the faces of the O-ring.